We're continuing our lesson on solving square root and cube root equations and working now with some real world problems. So here we've got an example with someone driving, and the amount of skid is modeled by the function s is equal to the square root of 30 times fd, where f is the coefficient of friction and d is the length of the skid marks in feet. So after an accident, a driver claims to have been driving the speed limit of 55. The coefficient of friction was 0.6, and then the length of the skid mark is 190 feet. So is the driver telling the truth? What you have to do here is plug in the values that were given and see if it works to match the skid length. So plugging in 55 for the speed and 0.6 for the coefficient, solving the equation, they'll end up with d is about 168. So if the driver had been traveling at 55 miles per hour, the skid marks would have measured about 168 feet. So because the skid marks actually measure 190 feet, the driver must have been driving faster than 55 miles per hour. So here we've got the diameter d in inches of a rope needed to lift a weight of w tons is given by the formula d is equal to the square root of 15w divided by pi. How much weight can be lifted with a rope with a diameter of 1 inch? So we're plugging in our diameter of 1 inch into our function here. So we need to isolate the square roots. They've got our instructions backwards here. We need to isolate the radical, isolate the square root. So we'll have to multiply both sides by pi. Well, 1 times pi is still pi. And then we've got the square root of 15w here on the left. So now we can square both sides. So pi squared is equal to the square root of 15w squared. And so pi squared will just be equal to 15w. To solve for w, you'd have to divide by 15, so you get pi squared over 15 is equal to w. If you plug that into your calculator, you'll get about 0.66. So a rope with a diameter of 1 inch can hold about 0.66 tons. If we want to convert that to pounds, a ton is 2,000 pounds. So if you do that multiplication there, that will get us to about 1320 pounds. The trunk length in inches of a male elephant can be modeled by L is equal to 23 times the cube root of t plus 17, where t is the age of the elephant in years. So if a male elephant has a trunk length of 100 inches, what is his age? So our length is 100, we'll plug that in. So 100 is equal to 23 times the cube root of t plus 17. So we'll need to subtract the 17. We'll get 83 is equal to 23 times the cube root of t. And then to isolate our radical, we'll have to divide by 23. So we'll get 83 over 23 equals to the cube root of t. So once you cube both sides, t will be on its own. So I can erase. And we'll get 83 over 23. Want to cube that, plug that into your calculator, you'll get about 47. So his elephant's age, if he's got a 100-inch trunk, would be about 47 years.